Okay, this demonstration is going to simulate what happens in your stomach when you have an upset stomach because you've had too much acid. So what we're going to use here is milk of magnesia. So if you have a tummy ache, you usually take milk of magnesia because it will neutralize the stomach acid. And in this case, the acid is going to be vinegar. It's going to be the simulation of what happens in your stomach. And so that you can see the pH equilibrium, the color change, we're going to use a natural plant indicator that comes from red cabbage. What I did was I boiled the red cabbage and I collected the juice into a water bottle here. But before we begin, regardless of this being, household chemicals, we are always going to wear a lab coat and our safety glasses. So again, what we have here is this is going to simulate what happens in your stomach when milk of magnesia neutralizes stomach acid if you've had too much, like let's say orange juice or something very spicy. So we have milk of magnesia in this cup, which is going to simulate your stomach. And I'm going to add the red cabbage juice indicator so that we can see what the color change will indicate, the pH, according to the scale that I've provided. And if we take a look at the color, red cabbage just on its own, you see it's a dark purple, but when I add it to the milk of magnesia, which is magnesium hydroxide, you notice that the color changes to kind of a bluish green color. So as you can see here, when I added the red cabbage juice, which is a purple color, when I added it to the magnesium hydroxide, the milk of magnesia, it turned to a green color. And if you can see here that on this scale, this color would indicate a pH of 10. Milk of magnesia has a pH of 10. Magnesium hydroxide, MgOH2 is its formula. Okay, so now I'm going to simulate if you've had too many spicy foods, or you drink some orange juice or any kind of juice, something too acidic in your stomach, what's going to happen to the color of this indicator is that it will change because this is an acidic environment. So magnesium hydroxide is basic because it has a pH of 10, but when I add the vinegar, which is like the spicy food in your stomach, it's going to turn color. As you can see, the color will change. So we have it on the bottom, you see, the vinegar sunk down to the bottom, and it's swirling around like a pinkish color. And that tells us that the pH is changing because the indicator color is changing. So the pH, if you look on the scale, it's going down somewhere around the 2 to 3 range. And you notice it's kind of staying down at the bottom and lingering for a while. Now it looks like it's turning a darker purple, which indicates it's going, increasing its pH up to about a 7 or so, pH of 7. And now if you look closely, you'll see that the color of green that we started with just the magnesium hydroxide, the milk of magnesia, has returned. So this, and I'll stir it just to show it's homogeneous. So this is how neutralization happens in your stomach. The magnesium hydroxide, milk of magnesia, just neutralized the vinegar. It went down to pinkish color at a lower pH, but then it went right back again to the pH of 10, as indicated by the color. We'll add a little bit more to see it happen again. You'll notice again it sinks down to the bottom. We have it going from a pinkish color, going to purple. So the pH goes lower, goes to purple, it's going increasing up again, and we'll see it go back up to close around 9 or 10, according to that pH scale, color indication. See, it's lingering longer around that purplish color now because we've added more vinegar to it. So therefore, it's taking longer to neutralize. Now you see it going to a darker blue. And it probably was going to be a lower pH than we started. So I'm estimating that this is going to now be around the 9 range instead of 10, because we see it's a darker blue, not just the green blue that we started with. Okay, so this is an example of a simulated stomach, and we used household chemicals to show this. We had our milk of magnesia, which neutralized the stomach acid. We had the vinegar, which is acting as the stomach acid. And to show that you could see the pH change, we had a natural indicator, which is red cabbage, the dyes in cabbage.
pH and pOH are a measure of how acidic or how basic a solution is, and for most solutions, is measured on a scale of 0 to 14. The lower the number, the more acidic the solution is, and the higher the number, the more basic the solution is. Neutral solutions, meaning not acidic or basic, have a pH of 7. pH is measured on what we call a logarithmic scale. That means that for every number the pH changes. The concentration of hydrogen ion atoms changes by a factor of 10. It becomes 10 times more acidic or basic, as you can see in the chart. pH equals negative log base 10 of hydrogen ion concentration. As you can see in the chart, milk of magnesia has a pH of 10 and vinegar has a pH of 3.
The following is an explanation of the molecule that causes the red or purple color in the red cabbage that was used as an indicator in this experiment. The anthocyanins are members of a class of compounds called the flavonoids. They are pigments found in a wide range of plants that are usually red, blue, or purple, depending on the pH of their environment. Because their colors change with the pH, they're often used as anti-acid-base indicators. Darn it, can I start over? Because their colors change with pH, they are often used in acid-base indicators. The positively charged oxygen atom, known as the benzopyrrolium cation, is usually associated with the chloride anion. Most anthocyanins are combined with sugar molecules to make glycosides called anthocyanins.